1036, escape a large maze. In a million by a million grid, the coordinates of each grid square are xy with zero is with x and y between 0 and a million. We start the source square and want to reach the target square. Each move we can walk to a directionally adjacent square in the grid that isn't in the given list of block squares. We turn true if it's reachable to the end, essentially. Okay. Okay. So I think the thing that they try to get you here in this problem is that n is a million, right? Or I guess in this case, yeah, n is a million, but it's n squared even, right? And that's what, 1,000 billion? Is that a trillion? A million? Okay, yeah. So it's like a trillion, right? So you can't do very naive things. Let's see, blocked. So there's only 20 spaces that are blocked. Yeah, so you don't have to worry about like, I don't know, anything too crazy. And blocks. Okay, cool. Yeah, I mean, I think a very a really a basic way to attack problems like this. Let's say you don't have a million by a million, and you have like some other end. Then you can solve this by like depth of search or binary search. A very simple connectivity problem, and it's not even distance, or in the sense that usually, well, not usually, but sometimes they ask you for like what is the shortest distance from x to y or something like, or from x, whatever, point A to point B, right? And in this problem, so this is just an extension of that, except that it's a million by a million, right? So I think what I would say, and there's only 20 block lengths, and that is a number that jumps at me, and what I would try to attack on this problem is kind of, well, like you have this million by million grid, but you could actually because you don't actually have to care about the distance. And if you care about the distance, you could still figure it out. Actually, it's just that you'll probably have to use like some kind of Dijkstra algorithm instead of breadth first search. But you can actually compress the graph because most of the graph is empty, right? And that's what I'm going to do here. And you may ask yourself like, well, what does it mean to compress a graph? Well, because blocked dot length, there's only 200 block points. That means there's at most 200 unique x points, right? 202 if you want to count the 0 and the 1 million or something like that, depending on. Oh well, 202 if you want to count the source and the target. There we go, right? But so yeah, so that's kind of. And now your n, when you come, so basically you would think about it as all the stuff like between 2 points, like in this case, maybe not this case, but you just compress all the space, and now you have a 200 by 200 grid instead, right? Or 202 by 202 grid, and then that is only like what, 40,000 cells. So very easy to do breadth first search. So that's what I'm going to do here. Yeah, with all that said. Hopefully that was understandable. If not, hopefully my code explains it, but I'll also explain it at the end. Definitely feel free to ask some questions. But yeah, okay, I should do, to call these. Coordinate or coordinates? I guess coordinates for dimension. It's kind of. Is that about it? Maybe I just need to do this. Then it should be okay. Wasn't sure actually. Maybe that would have been okay anyway. If you're in Python, definitely let me know. Maybe I would have done this in a cleaner way. But sometimes I worry about the order of operation. That's all. Also, probably should keep a counter instead of doing this all the time. I hope length is constant. Maybe I'll just keep a counter. It's probably the more responsible thing to do. Hmm. Oh, yeah. I mean, basically, it's just that blocked is a list of ints, and then this is a pen stump. I mean, not quite a pen, but it's just so that I go through the entire thing. Well, I don't know if that makes sense enough already, but basically it's just instead of doing like you can imagine a parallel way of doing it is me doing this, you know, code here, not this, like in blocked, and then the same code for like I don't know for coordinates in. I think this is understandable, hopefully, right? Like it's just put some in a list so that you do the code for each of the source and the target. Here, same code here, right? Yeah. So then now here I just do it in one array because for now I don't care about it because this code just maps kind of a coordinate to a compressed coordinate, if you will. So basically, what I'm doing here, just to explain this a little bit, is like okay, let's say I have and you can even sort these. I don't think. Oh no, actually no, it does matter. Whoops. Because then it would be not in the right order if I don't sort it. Good catch though. I would have got it hopefully, but basically, let me finish explaining. Like yeah, 5, 1, 6, 25, so forth. Um, Something like this, right? Well, now what I want to do is compress this to 1, 2, 3, 4. Oh, it's technically 0 index, say. So actually, is this. And that's what my code is doing, so that like it compresses the numbers together. Except for that's not what my code is doing because I forget to sort, but that's fine. Let's just do. Yeah, okay, fine. Uh, uh, and this way, yeah, and the way I do this is so that I don't forget to map uh, um, the x and the y's in the source and the target. So now it's sorted, but and now you can actually do something functional in this actually, but I you can refactor this, but I already had it written out to just being a helper on because it's just on XS and X mapping, right? So yeah, actually fine. I'll just refactor it. Try to be a whatever. um, array, do I actually do I need the X count? I guess so. Well, I guess not really. At the end. Oops. What the? I should just type this out. It's more effort to move, but okay, right. So basically now this allows us to do kind of map everything together. And then now it is straightforward-ish breadth first search or depth first search, whichever you like. But for 40,000 elements, I guess I worry a little bit about what you would call Stack Overflow. So yeah, but here, not, yeah. So now we want to append again, mapping of. Oh, and I guess the other thing that I have to do is now provide a block lookup, but that's fine. Like these are things that when you encounter it, it's like a few lines. So okay, let's just call it convert or map. No, map is a username. That's just from source, right? To new coordinates, which is and that's just x. I don't want to call it xf, right? And new target is equal to, and we could do the lookup easily. Oh, this is actually a list, not a tuple. That's annoying, but that's fine. Doesn't really matter. Okay, and then now we want to look up table for blocked. And this is also one of those things where I feel like if you're really good in Python, you could do it in one line, or maybe even just moderately, because maybe I could do it. Hang on. Yeah, so convert current for current and blocked. Okay, so maybe that is not that bad. That's for fun. Let's clean out the new blocked. Is that right? I start from 0, 0, and then to go 0, 2, but where's the 1? Oh no, these are, no, no, there's definitely feels wrong. Oh, well, I just didn't. I think I said it out loud, but I didn't actually sort it. Okay. Whoops. I think I mentioned it like 3, 4 times. I just did the refactor and then do it. Okay, there you go. That makes sense. And just for kicks, we could see what happened. Well, there's no blocked on this one, so maybe that's not interesting anyway. So I'll just say later. Okay. And then now, just well, is very standard thing. Oh, what I want collections.tech. Pop left. Okay, fine. And then now everything is in the new coordinates. So now we have to do that directions thing. Where was it? Is it just okay? 4 directional. Okay, so now we just do the and for this, I recommend having a systematic way that you type it the same way every time, because sometimes I miss it if I don't. But okay, so now this gets popped off. If oh, and I guess if this ends with this being keyless, then this returns false. Oh, actually, I think one thing that I'm just looking for now is what happens if you try to go out of bound. Um, I think that is an edge case because I'm not out of bounds, but if you try to like if you, I think the way that we would compress the map, we actually set the boundaries at the left and the right by accident of the min and the max elements. But what we actually want to bound by is the zero element. So okay, zero and I guess this is it. Okay, yeah, it's less than. So yeah, so I have to put these elements in there. So yeah, so this way, if you think about it as a box, these two numbers will always compress to the well, zero would always be compressed to zero for the first element, and 99999 will be the last element, whatever that might be. So now we can. So then, there's one edge case I'm thinking about is that like if you have someone like I'm just drawing dots and whatever, but like let's say you're trying to go from here to say here, and then now you have blocked here. If you compress it and then you don't go outside the bounds, then you can get there. But the obvious route is to go, to go left and then down and then around, right? Especially if you have space, which my initial case don't take care of. So that's why we needed to add these things here so that the mapping handles it correctly. Cool. Now we just want to say four. Okay. Well, yeah, four direction. Okay. Actually, I like it this way better. I guess I wish there was what you might call it, tuple addition. Something that I always like in theory, but okay. Now we just have to check that this is in bound, and this is actually where we need to. This is actually not good. We need this because how the way we did it, we actually dedupe. So yeah. No, let's just cache this. This shouldn't change afterwards. So. They're good. Well, if they're not in blocked. And oh, why did I do it this way? I mean, it's sensible, but actually we want a hash table or a set. Yeah, let's do a set actually. And also we haven't seen it before. I just seen it before. Then let's just say we've seen it before, and then we move to it by pushing it. And now we can also terminate early by if key is equal to new target, then return true. And that's it. Hopefully that's it. Man, my screen is a little dirty. Okay, well it's good to get at least one case right. Okay. Let's try this case that we talked about, which is, let's just say 3, 3. This is actually the same as the first one, except for let's just offset it by 1. And this should be good, or should be true, rather. If not, then maybe I just misunderstand the problem. So it's a good test too, though. Obviously, on the contest, you may not get that. You don't get a response back. So, judging is a little slow. Oh, yeah, I guess that's a good. Oh, okay, so it's not me. Okay, let's just see. Okay, cool. Yeah, I think I explained this problem okay enough. If not, please interrupt. But yeah, but I think the trickiest part about this problem is just how long did I take? About 20 minutes, but I think I was talking for it. But yeah, right. But I think the hardest part about this problem is just the kind of compressing the space. I mean, other than that, because after that is dynamic. I mean, breadth first search, but you can also choose your favorite search as long as breadth first search. Maybe a little bit edge casey on the things, but I think that actually may be a case that they try to get you on actually. And I guess this case, but otherwise straightforward once you got the space compression and kind of mapping them in a good way. And this is a pattern that I've done a couple of times, so I am familiar with. But the idea is, yeah, given like let's say these are your x coordinates of all your points, so they could be repeated, you know, in some way, and they're sorted because, well, if they're not, you sort it here, and I guess also it contains this. Yeah, you're just mapping it so that now, you know, this is 0, 1, this is still 1, but 2, 3, 4, 5, 6, 7, right? So then now these are your points on your x coordinates, and then we just have a lookup table that allow us to map it or figure out like, okay, this is this, and that's pretty much it. And then you have the y coordinates, which is the same, and then now you just do your breadth first search on your new grid graph. Yeah. There's a lot of typing. I mean, well, this was typed this way just because I don't know, because I was copying from another thing, but it definitely could have been a little cleaner. I mean, it's 61 lines, which is a little bit long. I'm just thinking about whether it. Oh yeah, for kind of complexity, where n is the number of blocked length, this is n squared because that's the number of space, and but for search is linear. Because that's the number of states, so it's n squared. Just trying to think whether like you would see this on an interview. I would say definitely breadth first search. You see breadth first search stuff on an interview, or either depth first search or breadth first search. I think on an interview, especially if you're whiteboarding, you could actually do it recursively, and because you don't have to worry about stack overflow things. Though the caveat is, I would also double check and ask the interviewer first whether like, hey, I'm going to try to do this with that first search. I know it's recursion, and I know that there's a possibility that may overflow. Is that okay? And stuff like that, right? Communication is probably the number one thing when you do an interview. Just you know, don't try to guess what your interviewer wants. Just ask. Usually they don't penalize for you. They don't penalize you for it unless you're like asking for how to solve the problem type things, right? Obviously, but if you have 2 or 3 different approaches, and you kind of analyze them and talk about the complexity and stuff like that, and you want to choose between which one to implement, I think just ask is fine, at least at the higher level. I think with this one, otherwise, yeah, I mean, this is a lot of typing, but but I think the core concept of it, the 2 components maybe a little bit separated out, is definitely breadth of search and search prompts are very easy to give and get on interviews, so that we expect that. And the space compression I've seen a couple of times. I don't know how. I don't know how often that comes up in an interview. I mean, I've seen it a couple of times in these kind of Leetcode things, but I don't know if I've ever heard someone really done it. So I don't know. But that may just be me. Take a quick look at the hint before I end this part. When we come stuck, there's a loop around this. Oh yeah, that's what I was saying. Around the target. What? There's a loop around to say what's the maximum squares it can have. Maybe there's a more clever way around it. I don't know. Maybe there's a mathematical solution. But yeah, I don't know. Maybe there's some. I guess there's. So I definitely did it with space compression and breadth first search because it applies to more stuff. But I think what these hints are saying is that there's a way to like just search the space around it. Because I think if you have 200 blocked, that means you only have to search. Actually, I think that's a clever solution as well that I did not do, but it's maybe worth kind of exploring is construct construct a graph or whatever or a grid of just like your starting point and like 200 points to the left, right, up, down, or something like that. I mean, I guess that's where your math is trying to go. Or actually, it wouldn't be that. It wouldn't be the entire graph. It would just be like if you imagine like a grid where you have the Manhattan distance, and so you have like essentially like a diamond-y thing, given the block length. So you do math on that, and kind of then you could after 200 steps or something like that, like you're always going to be done. And that's only on one side, right? So you have to like do some math, but I think their point is that at some point you can actually just return true because they can't hold you in if you do like a naive buffer search to some distance, and that's something that you get for binary. But obviously the way that I did it, you can extend it to dice true to get the distance much easier. Though maybe not. Maybe just a few more edge cases in another case. But yeah, overall, cute problem. But good luck if you get this on interview. But yeah.